Today we're going to talk about graphing a system of equations. So a system is two or more equations. That's what a system of equations is called. And the solution of a system of equations is all ordered pairs that make both equations true. So I have to make both equations true, and they will be ordered pairs. So what can happen when you graph two lines in a plane? Well, one thing that can happen is the lines can intersect. And have one point in common, so they have one solution. These are called consistent and independent. What else could happen? Well, the lines can be parallel. Giving no solution, and that's called inconsistent. And the third thing that can happen is the lines are the same, giving what's called infinitely many solutions. And this is different than all numbers because it's only ordered pairs that are on the lines that are the solutions. So don't use all numbers or I'll count it wrong. And these are called consistent and dependent. So the first thing we need to do is get our equations in the form y equals mx plus b and graph them. Now I think this one's going to go off our graph, so if we go up to 8 on the y-intercept, it's just going to be up 1 here. And then down 1 and left 1 would be here. It's very important probably to do a lot of points because we want to be very accurate in our graphing and drawing our lines. So it's helpful to draw a lot of points, maybe even use a ruler to make your line straight. And if you don't see a point of intersection, you can always come back and calculate slope this way. Y-intercept of -7, so that's all the way down here. And our slope is 4, so 1, 2, 3, 4, and over 1. So rise 4, 1, 2, 3, 4, right 1. Rise 4, 1, 2, 3, 4, and over 1. Draw our line. Oops, kind of missed my bottom point. Not a very straight line there. And this would be our point of intersection. So what are the coordinates? It's 3, 1, 2, 3, 4, 5. So the answer is 3, 5 is the solution. That's the only point that makes both these lines true. So that's what you're going to be doing when you're doing your homework, finding their point of intersection. Okay, if we want to graph these two, we first have to get them in the correct form. So I would need to subtract x from each side on this one. We don't have a lot of room here, so I'm going to kind of move over here. Get 2y equals -x plus 5. And then I'm going to divide by 2 and get y equals -1/2 x plus 5/2. On this one, I need to subtract 2x from each side. I'm going to kind of move up a little higher. I get 4y equals -2x plus 2. If I divide everything by 4, I'm going to get y equals -1/2 x plus 1/2. It can be a little difficult to graph the y-intercepts of halves, especially on this little graph, but we'll try. So this first one, again, that would be 2.5, so I'm going to go up 1, 2.5, and put a point, maybe. There we go. And my slope is -1/2, so I'm going to go down 1 and over 2, so it's going to look something like this, down 1 and over 2. And again, try to be fairly close when you graph it. I'm not sure, I don't have a ruler here, so hopefully I'll be fairly accurate. Now on this one, the y-intercept is 1/2, so it's going to be right here. And the slope is -1/2, so down 1 over 2, down 1 over 2. And graph that. And so what do we notice about these two lines? They are parallel, and you might have noticed this to start with because what do we know about parallel lines? They do have the same slope. So the solution to this is no solution because they do not have a point in common. So no solution on this. And again, we have to get it in the form y equals, so I need to divide everything by 2 for this one. So I'm going to get y equals -1/2 x plus 5/2. And on this one, it's already in the right form, so my y-intercept is 2.5, so go up 2.5. My slope is -1/2, so down 1 over 2, just like I did last time, down 1 over 2. And what do you notice about these two lines? They are the same line, not that I do it very accurately. And so what is the solution? There are infinitely many solutions, so that is what we put, infinitely many. And it is every ordered pair that's on this line. Now you can't use all numbers because it doesn't include an ordered pair like this out here, no. So that's why we call it infinitely many, but not all numbers.